Okay, we're going to go ahead and take a look at simplifying rational polynomials. So just like any fraction, if you're going to simplify the numerator and denominator, you need to cancel out common factors. So that means you're going to have to factor. So factor, 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 and then simplify any common factors by canceling them out. So the very first one, if we take a look at it, if you look at the numerator, we're going to go ahead and factor this by GCF. You don't have to know the names of how you factor, but you have to make sure you factor. I would always check for GCF first to make the problem simpler. So this one does have a GCF of a 3, so the 3 comes out. We're left with x squared minus 4. I can continue to factor. This is a difference of squares. So for the difference of squares, you're going to do a minus b times a plus b. So I still keep the 3 in there, and I turn this into an x minus 2 times an x plus 2. Okay, so that one looks good. Now let's go ahead and take a look at the denominator. The denominator is a trinomial, so we're looking at something that multiplies to 10 and adds to 7. I don't have to split it because it starts with just an x squared, not a number in front of there. So multiplies to 10, adds to 7, 5 and 2. So I'm going to rewrite this as x plus 5 times x plus 2. Again, you can cancel out any common factors now that we have it in factored form. So x plus 2 and x plus 2 are the same, making my final answer 3 times the quantity x minus 2 all over x plus 5. And the x plus 5 can be with or without parentheses, doesn't matter. Final answer. Okay, number 2, same type of idea. You want to go ahead and factor. Once again, the numerator has a GCF, so I can take out a 12x to the 4th, which leaves me with an x plus 3. The denominator, there's nothing to do here. It's simply just a 6x. So when I look to simplify here, I'm going to look to see if there's anything common between the 12 and the 6, which there is. 12 divided by 6 is 2. And then I'm also going to check x to the 4th over x. And when you're dividing, you can subtract exponents. So my final answer, 12 divided by 6 is 2. X to the 4th over x is x cubed. And then I still have that x plus 3. It's no longer a fraction. Okay, if I take a look at number 3, I would have you go ahead and do this on your own. So if you want to try this one, pause me. Otherwise, you can listen. So the numerator, once again, I'm going to go ahead and see what multiplies to negative 10 and adds to 9. So that would be 10 and negative 1. So I'm going to go ahead and split the middle with that one. So I'm going to write 10x minus x, bring down the minus 5, bring down the 2x squared. The first two have a GCF of a 2x. The next two have a GCF of a negative 1. If it starts with a negative, I pull out a negative. So 2x times x plus 5. I pulled out the negative 1, which turns it into a positive x plus 5. So those signs flip. Making my two factors, one of them x plus 5, which I pull out, which leaves me with a 2x minus 1. So my numerator is now factored. My denominator, I'm going to go ahead and see what multiplies to 25 and adds to 10. It's going to be 5 and 5. So you can write that as x plus 5 squared or x plus 5 times x plus 5. I'm going to write it as x plus 5 squared for a second. Notice when you cancel this out, you're going to cancel out an x plus 5 and one of the x plus 5 squared. So you still have one left. Because again, it's like saying you have 2 on the bottom. That's what a squared means, and 1 on top. So 1 and 1 would cancel. So again, doesn't matter which way you write it. They mean the same thing, and your final answer would be 2x minus 1 all over x plus 5. Again, with or without parentheses, because you only have the one factor in the numerator and denominator. So that's as simple as it can get when it's just a fraction. Now we're going to go to multiplying and dividing. So we've got two fractions, and there's either a multiplication or a division sign between them. When you do this, the first step really isn't any different. You're going to factor as much as possible. If you're dividing, you're going to have to turn to multiplication by multiplying by reciprocal. So you want to make them multiplication problems. And then you're going to go ahead and simplify, just like in the last step, any common factors. So it's really the same as before, unless it's a division. So I'm going to go ahead and I'm going to factor just more parts. There's 4 parts to factor now. So my numerator, I'm going to be looking for something that multiplies to negative 12 and adds to 4. That would be 6 and negative 2. So I'd write that as x plus 6 times x minus 2. My denominator for this one, I would be looking for what multiplies to negative 6 and adds to 1. That would be 6 and, that would be 3 and negative 2. So my denominator would be 3 and negative 2 times, if I go ahead and take a look at the next one, let's say, let's go pink. X squared minus 9 is a difference of squares, so x minus 3 times x plus 3. And then our last bottom one here, this is a GCF problem, so I can take out a 2x, leaves me with an x plus 6. So there's the 4 different polynomials that I factored. Now I'm going to see what's in common. So anything with the top and the bottom, x minus 2 and x minus 2. Because you're multiplying and you multiply straight across, it's kind of like they're on the same line. So as long as the top has it and the bottom has it, the numerator and denominator, you can cancel and cancel. Cancel and cancel. So really, all that we're left in this problem is an x minus 3 over a 2x. Done. Okay, as we take a look at number 5, this is one that you have to be careful of. It's a division. Because it's division, the first thing I would go ahead and do, so that I do not forget to do it, is I would turn this into multiplication, and I would make the 6x on the bottom and the 5x cubed plus 20x squared on the top. So I would right away flip it because of the division, and now it's multiplication. So really, number 5 is now the same as number 4. Factor all 4 parts and then cancel. If you feel confident, pause me and go ahead and try that yourself. All right, so this first one here is a GCF problem. So it has a GCF of 6x cubed, which is going to leave me with x minus 4. My denominator down here is going to be a difference of squares, an x minus 4 times an x plus 4. Times, now if we go ahead and we take a look at the top right is also a GCF problem. This has a GCF of a 5x squared. When I divide that out, it leaves me with an x plus 4. And then the 6x, I can't do anything with that. So it's just a 6x. Again, when you're multiplying, it's like saying it's one fraction. You multiply the top across and the bottom across, but you're not actually going to multiply. You're going to cancel. We want it factored so that you can cancel. So something I can cancel. X minus 4, x minus 4. X plus 4, x plus 4. So what I'm left with and how you decide to solve it is kind of up to you. So if I zone in on these coefficients here, 5, 6, 5, and 6. 6 times 5 is 30. 30 divided by 6 is 5. Or you can notice that the 6's are the same, so you can just cancel the 6's. Or again, multiply and then divide. You're still going to get an answer of a 5 in the numerator. And then, again, it's kind of up to you. I'm going to zone in on these x's right here. We've got x cubed, x squared over x. So on the top, we actually have x to the 5th. There's 5 of them. And on the bottom, we have 1x. So that leaves you with x to the 4th. Or you can think about canceling out one of the x's and turning this from 2 to a 1. And then you can add the 3 plus 1 is a 4. So a couple of different ways to think about how to do that, but both getting you to the same answer of 5x to the 4th. Okay, so we simplified fractions, we've multiplied, we've divided. The next step is going to be adding and subtracting. When you add and subtract with fractions, you need a common denominator. So the first set of problems, we have a common denominator, and then we'll talk about what to do when you don't have a common denominator. So if we take a look to add and subtract, you must have a common denominator. These steps are different. You're going to, once you have a common denominator, add or subtract by combining like terms. That's different than above because it was multiplication and distribute, or multiplication and division. After you do that, then you're going to factor and simplify. So this has an extra step in the beginning where you're going to add across. So first you're going to check to make sure they have the same GCF. In this problem, they do. They both have x squared minus x minus 12. when they have the same GCF, you can just go ahead and add across. If you think about fractions, if I put a quick example up here, if we have 1/4 plus 2/4, right? You go ahead and you add 1 plus 2, which is 3, and the 4 stays. Same thing in this next problem. We're going to add, where I highlighted in green, and that is going to become x squared. 3x plus 2x is a 5x plus 6. So we add the numerator, and the denominator stays the same. X squared minus x minus 12. You don't add the denominator, just the numerator. Now that you've added, now it's just a fraction problem, which means you're going to factor and cancel. So this top one here is the x factor, multiplies to 6, adds to 5, 3, and 2. Our denominator, same idea. We're going to go ahead and multiply to negative 12, add to negative 1, so negative 4 and 3. And then you can cancel. The x plus 3's cancel. So my final answer is an x plus 2 over an x minus 4. And you can't cancel out those x's or cancel out 2 over negative 4 because x plus 2 is stuck together. You'd have to cancel out an entire x plus 2. That is the final answer. Okay, let's take a look at the next one. Again, you want to check that the denominators are the same. They are. They're both 5x. So in this case, we're going to go ahead and subtract the numerator. This is where you have to be very careful. When you are subtracting the numerator, you are subtracting all of 4x, and then you're subtracting 6. You're not adding 6. You have to carry that negative sign to both terms. So that is a common error. People have a plus 6 there, and then it doesn't work out. My denominator is the same, so it's a 5x. So again, you add the numerators before you do any factoring, or subtract the numerators before any factoring. So now if I combine my like terms, 19x minus 4x is a 15x. Oh, nicely. 6 minus 6 is gone, so I really just have 15x divided by 5x. So once again, you're looking at 15 divided by 5 is just a 3. And then you're going to have x over x, which cancels out because they are the same thing. So the x's are gone. So we really just have 15 divided by 5, and our entire answer is just a 3. Now again, that's going to be different than the next problem. What's different about it? If we take a look, it's still adding and subtracting, but if you notice, the denominators are not like. When denominators are not like, you have to make them like. For example, when you take a look at a fraction, let's say we have 1/2 plus 1/4, you can't add those until you change the 1/2 to be a 2/4. Once you do that, then you can add across, because again, they have to have a common denominator before you can add across. So you've got to be very careful. So how do we do that? Well, in the fraction example, I multiplied the top and bottom by 2. I took 1/2 and I multiplied 1 by 2, and I multiplied 2 by 2 to be 4, so that the 4's are the same. So we're going to have to be multiplying factors in. So that's where it says here, if the denominator is not the same, then multiply each term by the missing part of the LCD. And then all the steps 2 through 4 are the same as the steps above here. But again, you got to get it to be a common denominator. So let's see, what should be the common denominator in this example? If we take a look, let's think what our LCD is going to be. Our LCD is going to be made up of x plus 4 times x minus 2. So in number 8, this first fraction is missing an x minus 2. So you would multiply by x minus 2 over x minus 2. Our second fraction here is missing a x plus 4. So we would multiply x plus 4 over x plus 4. So now our denominator is the same. Now we have a denominator that is going to be, and it's already factored for us, x minus 2 times x plus 4. Now the numerator, right here, we're going to have some work to do. It's x minus 2 times x minus 3 plus, because of that plus sign, we're going to have to first multiply and then add and distribute. So what we're actually doing here is we are going to multiply x minus 2 times x minus 3, which this is going to be a FOIL problem, plus x times x plus 4. And this is just distributing. And then we're going to combine our like terms because, again, it says plus. So I'm going to go ahead and FOIL. X times x is going to give me x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is a positive 6. So I FOILed. Plus, when I distribute, x times x is x squared. X times 4 is a 4x. Wonderful. I did nothing with the denominator. I'm going to keep it exactly the same. X minus 2 times x plus 4. The numerator, I'm still simplifying. X squared and x squared is a 2x squared. Negative 3x, negative 2x, and a positive 4x. If I go ahead and I combine those, that is going to give me just a minus x. And then the plus 6 is by itself. I'm going to keep the denominator factored. Now I'm going to factor the numerator. So for the numerator, it needs to multiply to 12 and add to negative 1. 6 and 2. 4 and 3 does not work because they both have to be positive 4 and 3, which does not get you to add to a negative 1, or negative 4 and negative 3, and that's a negative 7. So this one doesn't factor. When that happens, you're done. It's less work to do. This is the answer. Complete. Does not factor for the numerator, so things cannot cancel. Now, let's take a look at number 9. Again, if you take a look at number 9 here and you look at these denominators, they're not the same. You need them to be the same. So in this case, in order for them to be the same, it's easiest to find the LCD once you have it in factored form. So I'm going to cross off x squared minus 2x minus 3, and I'm going to rewrite that as x minus 3 times x plus 1. What multiplies to negative 3 and adds to negative 2? Negative 3 and 1. The second side, what multiplies to 6 and adds to negative 5? We've got a negative 6 and a positive 1. Okay. So when I see what is missing from this side, I am missing well, let's see, what is the LCD? The LCD is going to be an x minus 3, an x plus 1, and it looks like the other one has an x minus 6. So this one here is missing an x minus 6. So I've got to multiply by x minus 6 on the top and x minus 6 on the bottom. My second fraction here is missing an x minus 3. So I'm going to multiply by an x minus 3 and an x minus 3. Minus. Okay. Just like the last one, it's going to take a little bit of work here. So I'm going to go ahead and I need to FOIL, subtract that distribution. So this is like saying, ooh, actually I think I changed the problem into just a 4x. We're going to cross off this minus 1 because I changed the problem and I did not change the note. So it's just a 4x there, which is great. It makes the problem easier. We don't have to actually FOIL now because now we simply have 4x times x minus 6 minus 3 times x minus 3. Hold on, I'm thinking for a second. Oh, you know what I'm thinking? Because this is factored wrong. If it has to add to a positive 6, they're both positive or they're both negative. So this is a minus 3 and this is a minus 2. Whoa, I got to go back. We're going to have to probably change our LCD here. So this is what we're going to do. We're going to erase this. We're going to erase this. We're going to erase this for a second. Okay. So because I made a error in the first step, it changes everything. Sorry about that, guys. So the LCD here, now that I've factored correctly, is going to be we have an x minus 3, an x plus 1, and an x minus 2. See what happens when you factor incorrectly? That is the correct one. So when I look at this first one and I think, what am I missing? This time I'm missing an x minus 2. So I'm going to have to multiply the top and bottom by an x minus 2. Here we go. The second fraction is missing an x plus 1, so I'm going to multiply the top and bottom by an x plus 1. Okay, now we're rolling. Now we're going to go ahead and follow those same steps here. We are going to do a 4x times an x minus 2 minus 3 times x plus 1. So now we can add or subtract across because the denominators are the same. What is my denominator? My denominator is x minus 2, x minus 3, and x plus 1. They have a common denominator, so you can write it together. So we're going to go ahead and simplify. 4x times x is 4x squared. 4x times negative 2 is negative 8x. Negative 3 times x is negative 3x. And negative 3 times 1 is a minus 3. And it's all being divided by x minus 2 times x minus 3 times x plus 1. So my numerator, I'm going to go ahead and combine my like terms here, negative 8x minus 3x, and that is going to become 4x squared minus 11x minus 3. And again, nothing has changed with my denominator. Now I'm running a little bit out of room, so I'm not going to keep writing my denominator because I need to factor this. So I'm going to factor this by seeing what multiplies to negative 12 and adds to negative 11. So that's going to be a negative 12 and a 1. So I'm going to go ahead and split the middle here between a negative 12x and a 1x. I'm going to group the first two. The first two have a GCF of a 4x. The second one has a GCF of a 1. So that's a 4x, x minus 3. Pull out a 1, leaves me with an x minus 3. My x minus 3's line up, and I have a 4x plus 1. So I would rewrite that as, put this over here, this is my numerator, just so you can kind of label your work when you go back to it, is 4x plus 1 times x minus 3. Perfect. That is factored. Because again, you cannot cancel until everything is factored for your last step. So you've got one fraction and everything is factored, which my x minus 3's cancel out, which leaves me with my final answer, which I'm going to squeeze in here, 4x plus 1 over x minus 2 times x plus 1. And we're done there. All right, wonderful.